Lesson 1.2 covers applications of Venn diagrams. Before we look at these applications, let's look at the counting formula for two sets. If the number of elements in set A is 9 and the number of elements in set B is 12, and the number of elements in the intersection of A and B is 3, I want to find the number of elements in the union. So set A contains 9 elements, set B contains 12. These sets overlap because they have an intersection and it contains 3 elements. And I want to find out what are the total elements in A and B. So let's look at a Venn diagram. And again, I draw sets A and B overlapping because the intersection did have 3 elements in it. Let's begin by labeling that intersection. I know that there are 3 elements in the intersection. I don't know what sets A and B are, but let's just think about it, the previous example, and let set A be the students enrolled in a math class and set B be the students enrolled in an English class. So that means there's 3 students that are enrolled in math and English. Now let's look at set A. Set A contains a total of 9 elements. I've already got 3 listed in the intersection, so that leaves me 6 remaining for the other part of A. If I add the 6 and the 3 together, that would give me the total elements in set A, which were 9. Let's do the same for set B. Set B contains a total of 12 elements. Well, of those 12, I've already listed 3 of them in the intersection. So if I subtract those 3 from the 12, that gives me 9 for the remaining part of B. Now if I want to find the number of elements in A or B, A union B, I'm going to add the 6, the 3, and the 9. So I get the number of elements in the union of A and B is 18. On problems with only 2 sets, there's a formula for finding this number of elements, so I don't have to draw the Venn diagrams every time. Before we look at that formula, if we just added the number of elements in set A to the number of elements in set B, the 9 plus the 12 would give us 21. Well, as we saw from the Venn diagram, we only had 18 total elements. What's happening are the 3 elements in the intersection. The 3 elements in that intersection were the elements that were included in set A and also in set B. So when I add the 9 and the 12, those 3 elements are getting added twice. Since those 3 elements have been added twice, what I'm going to do is subtract them out one time. I only want to count those 3 elements once. So if we take the 21 we got from adding the elements of set A to the elements of set B, and then subtract the 3, which are the 3 from the intersection, we would get the 18 elements that we found using the Venn diagrams. This leads us to the counting formula for 2 sets, and that's the number of elements in the union is equal to the sum of the elements from each set, the number of elements in A plus the number of elements in B. But I've got to subtract the intersection. Since that intersection has been counted in A and counted as part of B, it's been counted twice, so I need to subtract it once. Let's look at a couple of examples. Let's say set A contains 50 elements, set B contains 125 elements, there's 25 elements in the intersection, and I want to find how many elements are in the union. So we'll begin with using the formula. So I add the number of elements in A plus the number of elements in B, and subtract out the intersection. So I end up the number of elements in the union is 50 from A plus the 125 from B minus the 25 in the intersection. Those 25 elements have been counted in A and B. They've been counted twice, so I need to take them out once. So that leaves me that the number of elements in the union is 150. In the next example, set A contains 215 units, set B contains 65 elements, and the intersection contains 10. So to find the number of elements in the union, begin with the formula. This time we're going to have 215 plus 65 minus 10. So this gives us the number of elements in the union is 270. In the next two examples, we're given the number of elements in the union and we want to find the elements in the intersection. So set A contains 45 elements, set B contains 85 elements. The union, which is the total number of elements, is 100. I want to find how many are contained in each set. So let's begin with the formula. The union contains 100 elements, so I start with 100 equals. Set A is 45. The number of elements in set B is 85. And then I'm subtracting the number of elements in the intersection. So treat this just like an algebra equation. You're going to add the 45 and the 85 and get 100 equals 130 minus the number in the intersection. Now subtract 130 from each side. So you get negative 30 equals negative the number in the intersection. Well, to get rid of the negative sign, divide each side by negative 1, so you get that there's 30 elements in the intersection. In the next example, the number of elements in set A is 150. The number of elements in set B is 240. There's 320 total elements. The union contains 320 elements. And I want to find the number of elements in the intersection. So begin with the formula. The number of elements in the union is 320, so 320 equals 150 from set A plus the 240 from set B, and then we subtract the intersection. So again, solve this just like an algebra equation. Add the 150 and the 240. So you get 320 equals 390 minus the intersection. Now subtract 390 from each side, so negative 70 equals the negative number of elements in the intersection. To get rid of the negatives, divide each side by negative 1. So you get 70 is the number of elements in the intersection. Now we're going to look at how to use Venn diagrams to solve application problems. So the formula mentioned above only applies if you have two sets. If we're dealing with three sets, it's easier to use the Venn diagrams. And we're going to follow the basic procedure used to follow the previous examples with two sets. We're just going to extend it to three sets. So look at the first example. In a survey of 75 college students, it was found that of the three weekly news magazines, Time, Newsweek, and U.S. News, 23 read Time, 18 read Newsweek, 14 read U.S. News, 10 read Time and Newsweek, 9 read Time and U.S. News, 8 read Newsweek and U.S. News, and 5 read all three magazines. So in order to answer the questions that follow, let's begin with the Venn diagram. And since we have 3 sets, we're going to draw 3 circles in the Venn diagram. And if you notice, there were students that read all 3, so I need these 3 circles to all overlap. You can label the circles with any variables you want. I just picked N, T, and U that correspond with the names of the magazines. That's easier to use. So set T represents those that read Time, N represents those that read Newsweek, and U represents those that read U.S. News. Always begin with the intersection for all 3 sets. In this case, there were 5 students who read all 3 magazines. So in that very center area where all 3 circles intersect, I'm going to put a 5. Now find 2 sets that overlap. So we're going to take these sets 2 at a time. First, we know 10 students read Time and Newsweek. So look at the area where Time and Newsweek overlap. That's this oval area right here. There's 10 students in that oval total. I already have 5 listed in the intersection for all 3 sets, so that's going to leave me 5 more outside of that central intersection. If I add these 2 5s, I get my 10 total students that read Time and Newsweek. Next, I know 9 students read Time and U.S. News. So look at the intersection for Time and U.S. News, and that's this oval right here. That oval is going to contain 9 students. I already have 5 that read all 3, so that's going to leave me 4 that read just Time and U.S. News. Then we know 8 students read Newsweek and U.S. News. So that's this oval right here where Newsweek and U.S. News overlap. That oval is going to contain 8 students. I already have 5 in there from my intersection of all 3. So that leaves me 3 that just read Newsweek or U.S. News. Now we want to find the remaining students for each set. So I know 23 students read Time. So the entire circle for the set of students that read Time are going to contain 23 students. Well, I already have 14 listed. I've got 5, 5, and 4. So if I add those, I already have 14 students there. So take the 23 and subtract the 14, and that leaves me with 9 that just read Time only. Next, we know 18 students read Newsweek. Well, look at your circle for Newsweek. It already contains 13 students. I've got the 5, the 5, and the 3. So take the 18 and subtract the 13, and that leaves me with 5 that just read Newsweek. And finally, I know 14 students read U.S. News. So look at your circle labeled with a U for U.S. News. It already contains 12 students. So take the 14 and subtract the 12, and that leaves me with 2 that just read U.S. News. Now finally, I want to find out how many students read none of these. That would be the number of students in the box inside my universal set, but not in any of the circles. And I mentioned before, we usually label the universal set with a U, but this time I've used U for my U.S. News. So I just didn't label my universal set with any variable. I left it blank. If I add all of the elements from all of the boxes, I have the 9 plus 5 plus 5 plus 4 that all came from the times, and then add the 5, the 3, and the 2, those remaining elements. That gives us a total of 33. Well, the problem told us that we surveyed 75 students. So that means that 42 students, and I get that from the 75 minus 33, those 42 students do not read any of these magazines. This number is placed outside all three sets, and usually we place it in the upper right-hand corner of the box, but you can put it anywhere you want. Now with our Venn diagram completely labeled, let's answer our questions. How many students read none of these three magazines? That's the number outside all three circles, so that would be the 42. How many students read Time alone? So that means it's the number of students inside my circle for Time, but not inside the other circles. So that was just the 9 students. How many students read Newsweek alone? That's the number of students inside the circle for Newsweek, but not inside the other circles. So that would be my 5 students. And then how many students read U.S. News? Look inside your circle for U.S. News, but not inside the other circles. So that would be 2 students. And then how many students read neither Time nor Newsweek? So if I could just take a circle and cover up the Time circle and cover up my Newsweek circle, I want to block off all of these numbers. Well, the only 2 numbers that are not inside Time and not inside Newsweek are the 42 that read none of the magazines and the 2 that only read U.S. News. So the 2 plus the 42 gives me 44 people read neither Time nor Newsweek. Let's look at the next example. In a survey of 75 customers, 12 indicated they were going to buy a new dishwasher, 18 said they were going to buy a new refrigerator, and 24 said they were going to buy a new stove. Of those surveyed, 6 were going to buy a dishwasher and a refrigerator, 4 were going to buy a dishwasher and a stove, and 10 were going to buy a stove and a refrigerator. And of those surveyed, 1 person said they were going to buy all 3 items. Now to answer the questions, again, I want to draw a Venn diagram. So I begin with a Venn diagram with 3 sets. The circle for D represents those people buying a dishwasher. The circle for R represents those people buying a refrigerator. And S represents the people buying a stove. You can label these with any variable you want, and you can put these in any order you want. When you begin inserting the numbers, always begin with the intersection for all 3 sets. In this case, 1 person said he was going to buy all 3 items. So in that very center intersection, I'm going to put a 1. Now we want to take the intersections 2 sets at a time. So first, we were told 6 people were going to buy a dishwasher and a refrigerator. So in the intersection, in the overlap area for circles D and R, for dishwasher and refrigerator, there's going to be a total of 6 people. Well, I already have 1 person that's going to buy all 3, so that leaves me 5 that are just going to buy a dishwasher and a refrigerator. Well, next, 4 people were going to buy a dishwasher and a stove. So in the intersection for sets D and S, I want a total of 4 people. I already have 1, so that means I have 3 left. Finally, 10 were going to buy a stove and a refrigerator. So in the intersections for S and R, I'm going to have 10 people. That intersection already contains 1 person, so I have 9 left. Now we want to find the remaining number of people for each set. 12 people are going to buy a new dishwasher. So the circle for set D, the people buying a dishwasher, is going to contain a total of 12. Well, I already have 5, 1, and 3, so I already have 9. That leaves me 3 left that are just going to buy a dishwasher. Next, 18 people are going to buy a refrigerator. Well, if you look at your circle for R, it already contains 5, 1, and 9, so it already contains 15 people. If I take the 18 and subtract these 15, that leaves me 3 people that are just going to buy a refrigerator. And finally, 24 people are going to buy a new stove. Well, in my circle for S, I already have a 9, a 1, and a 3, so I already have 13 people. If I take the 13 away from the 24, that leaves me 11 people that are just going to buy a stove. And then finally, I want to know how many people are going to buy none of these appliances. So if I take all of the numbers I have listed and add them, I get 35. Since I surveyed 75 total people, that leaves me 40 customers that are going to buy none of these. Take the 75, subtract the 35 that I have labeled, and that leaves me with 40. So in my universal set, but not inside any of the circles, I'm going to list a 40. Now let's answer our questions. How many were going to buy none of these items? That's the 40 that we just found. How many were going to buy only a refrigerator? Well, that's the number of people in set R that are not in the other sets, so that would be 3. How many are going to buy only a stove? That's the number in set S that are not in the other sets, so that was 11. And how many are going to buy a stove and a refrigerator, but not a dishwasher? So look at the intersection for refrigerator and stove. That was the 10, the 9 plus the 1. But I don't want to include the one person that's buying a dishwasher, so that just leaves me with 9. Let's look at our next example. In a survey of 85 amusement parks, it was found that 25 had a hotel on site, 55 had water slides, and 38 had a wave pool. 13 had a hotel on site and water slides, 17 had water slides and a wave pool, 10 had a hotel on site and a wave pool, and 7 had all 3 features. So I want to know how many amusement parks surveyed had only water slides and how many had exactly one of these features. So again, I'm going to begin with a diagram containing 3 sets. I'm using H to represent the parks with a hotel, S to represent the parks with slides, water slides, and P to represent the parks with wave pools. I didn't use a W because water and wave both start with W. And again, you can label these any way you want. So begin with the intersection of all 3. In this case, 7 parks had all 3 features. So in the very center, in the intersection for all 3 circles, I'm going to put a 7. Now let's take the intersection of these sets 2 at a time. So we're told that 13 had a hotel on site and water slides. So let's look at the intersections of sets H and S for hotels and slides. This oval is going to contain a total of 13. I already have 7 listed, so that leaves me with 6. Next, I'm told 17 parks had water slides and a wave pool. So the intersection for sets S and P for slides in the pool is going to contain 17. Well, I already have 7 there, so that leaves me 10. And next, 10 parks had a hotel on site and a wave pool. So the intersections for H and P for hotels and pools is going to contain 10. I already have 7, so that leaves me with 3. Now we want to find the remaining numbers for each set. 24 parks had a hotel on site. So my circle for H, for hotels, is going to contain a total of 24. I already have 16 listed, the 6 plus the 7 plus the 3. So take the 16 away from the 24, and that leaves me with 8 that just have hotels. Next, 55 had water slides. So look at your circle for S. It should contain a total of 55 numbers. Well, I already have 6 plus 7 plus 10, which is 23. So take the total of 55 and subtract the 23, and that leaves me with 32 that contain just water slides. Finally, 38 parks had a wave pool. So my circle for P is going to contain a total of 38. I already have 10 and 7 and 3, so I already have 20. So take the 20 away from the 38 and you're left with 18. Now I want to find the number of parks that have none of these features. So add all of the numbers that we have, and this gives us a total of 84. Now look back at the problem to find out how many were surveyed. Well, there were 85 parks surveyed, so that means one park had none of these. I take the 85 total, subtract the ones that I already have listed, and that leaves me the 1. Now let's look to answer our questions. How many of the amusement parks only had water slides? So look at your circle for S. I want the number that's in S but not in any of the other circles, so that was the 32. So 32 parks only had water slides. Now I want to know how many parks had exactly one of these features. So of the water slides, 32 parks only had water slides, 8 parks only had hotels, and 18 parks only had wave pools. So if I add these, 32 plus 8 plus 18, that tells me 58 parks had only one of the features we were focusing on. Now let's look at our last example. A survey on favorite kinds of books shows that 9 people like mysteries, 10 like adventure stories, and 8 enjoy biographies. 3 of the people read only mysteries and adventures, 4 read only adventures and biographies, and 4 read only mysteries. 2 read all 3 of these books, and 5 liked none of these books. And this time we're asked how many people were surveyed. So we're going to begin with the Venn diagram with 3 sets. I'm going to use M for mysteries, A for adventures, and B for biographies. So let's begin with the intersection for all 3 sets. We're told that 2 people read all 3 kinds of these books. So I'm going to put a 2 in the center. Now I want to find the intersection for the individual sets taken 2 at a time. This time the wording was just a little bit different. It says 3 of the people read only mysteries and adventures. It doesn't say that 3 read mystery and adventures. It says only mystery and adventures. So this time when I'm looking at that 3, it's not including the people that read biographies. So this part of the intersection, just the M and the A, but not including the B, will contain 3. I'm told 4 read only adventures and biographies. So look at your intersection for adventures and biographies. That 4 is not including the 2. So I'm going to put all 4 in the intersection for A and B, leaving out the part where all 3 overlap. Then I'm told that 4 read only mysteries. So if I look at my circle for M, if I only want to consider the ones that read mysteries, that's everything in the circle for M that's not in any of the other circles. So my 4 is going to be in the area for M that's not in any of the other circles. Now let's look at the rest of the information we're given. 9 people like mysteries. So my total for the M circle is going to contain a 9. Well, if I look, I already have a 3, a 2, and a 4 up there. So I already have all 9 people listed. So this remaining portion for circle M cannot contain any people because there's only 9 total people that like mysteries. Next, there's 10 total people that like adventures. It doesn't say that just like adventures. It says there's 10 people that like adventures, so that's my total. Well, if you look at your circle for A, I already have a 3, a 2, and a 4, so I already have 9 people. That leaves me with 1 person that likes adventures only. Next, 8 people enjoy biographies. So that's my total people for biographies is 8. In the circle for B, I already have a 4 and a 2, so I already have 6 people. That leaves me with 2 people that only like biographies. Now this time I was told that 5 like none of these type of books. So that 5 is going to go in my universal set but outside of all the circles. Now to find how many people were surveyed, I'm going to add all of the numbers that I have listed. So I have the 1, the 3, the 2, and the 4 from set A, and then add in the 4 and the 0 from set M, the 2 from set B, and then the 5 that were in none of the sets. And this gives me 21. So there were 21 total people surveyed.